Lastly, we have Professor Peter Railton. He is the Gregory S. Kavka Distinguished University Professor and John Stephenson Perrin Professor of Philosophy at the University of Michigan, where he has taught since 1979. He's the author of the book Facts, Norms, and Values, and which is a collection of his major papers in ethics, and a co-editor with Steve Darwall and Alan Gibbard of Moral Discourse and Practice, Some Philosophical Approaches. And today he's going to talk about machine morality, building or learning. Thank you. Welcome.
Well, the first thing you're going to see is that moral philosophers don't have very interesting looking slides. And so I'll have to ask you to forgive me for that. And I know it's late in the day and you've already had an enormous amount set before you. So I'll try to make this as painless as I can. And I hope to say something that people can disagree with also. I call it building or learning. And really what I'm going to talk about is building for learning. I was interested to learn that we're supposed to talk about the short run today, and it's a big mistake to ask philosophers to think hard about the short run. But if I do think about it, I guess one thing that occurs to me is that if we in humans and AI agents, and I'm really focusing on artificial intelligent agents as opposed to sort of other kinds of systems, for us to work together, aware of the limitations of AI as it now stands, but somehow mindful of the need for the development of AI's potential to make this a better place, and to do that somehow at a pace that does not outstrip our capacity to regulate it or its capacity to regulate itself. It might seem enough just to teach AI agents what we want and design them to deliver this and no more. Then the challenge would be keeping them on task. With all the dangers of hacking and security, I hope I get some reassurance on this point. But this can't be the best model for realizing the promise or avoiding the threat of artificial intelligence, because our own wants and values, certainly mine, require critical assessment and not just replication and implementation. And as we saw from the previous talk, AI is already helping us figure out what we might want as individuals, or as doctors, or perhaps in social decision-making, helping us to gain and share and use knowledge and experience to approximate better informed preferences and policies, and in the small and in such larger questions as how to regulate the economy. So we don't want just to download whatever we want onto these systems. And similarly, we're going to be living with robotic agents, it seems, increasingly, and as I get older, I'm being told that that's perhaps my fate. And the more that goes on, the more that they'll need to be actually sensitive to what's going on in our lives. And that will require them to be more autonomous because, as we know, you can't make a very good companion out of a creature that is just a prosthesis for your own will and beliefs. Okay, so this actually sounds kind of familiar. We've already been developing ways of tackling such problems, I think, since this is the trajectory of human moral development. AI systems, as we now understand them, lack much of the equipment with which humans take on the task of moral development. They lack, as far as we can tell, consciousness. They don't seem to have feeling or caring in the same way humans do. They don't seem to have the same capacity to appreciate value or for respect. And so you might think, well, from the outset, we're up the creek. These AI systems can't do anything like morality. All we could do is just teach them constraints and rules. And it has been argued that the kind of intelligence currently in view in artificial intelligence work, namely the capacity to predict and simulate, to make choices relative to well-defined objectives, to learn from experience how to do this better, that's essentially orthogonal to morality. And that might be right. But as we increasingly interact with such systems and allow them to participate in our own lives in decision-making, the question of what it would take for them to be intelligent at that kind of existence might get a somewhat different answer than simple orthogonality. You know, that's the question I put to myself after this morning's session, and I'm trying to figure out how a philosopher might say something about it. So, and when we think about the development of moral autonomy in humans, a key feature is that morality is developed in a social context, that we learn morality, so to speak, in a social context, and our capacity to form and realize whatever values we have on the basis of experience is integrated into our social existence. And so thinking about how artificial systems might acquire morality should be thinking of them as social creatures and not simply as creatures who are intelligent, but who are socially intelligent. Now, here's a simple model, and this is one thing philosophy can contribute. We're big on simple models. So as we saw this morning, very plausibly, self-preservation would emerge as a sub-goal of an intelligent system seeking to realize many given objectives. It's like the warning we get on airplanes that parents should put on the oxygen mask first in order to be able to assist the infant. Self-preserving systems would emerge as a part of their job of delivering whatever objectives we set. Now, Hobbes argued that creatures capable of self-regulation and seeking to preserve themselves, if intelligent, could, by playing out the consequences of non-cooperation, come to realize that a social pact of mutual restraint and cooperation to which they could, if self-regulating, hold themselves, would actually be a subpart of their most promising general-purpose problem-solving plans. That is to say, if you want general-purpose problem-solving and you're a creature like this and you're amidst other creatures like this, you would, as a good intelligent Hobbesian agent, realize the value of entering into these kinds of mutual restrictions. And so even from the task of self-preservation, Hobbes points out, we get something that takes some of the shape of morality. And as we enter autonomously into relations with these systems capable of learning from experience to become better at such interaction, we could see perhaps how behaving intelligently in such situations could involve the formation of social relations that bear many of the hallmarks of morality. This is not a claim that such systems would be moral agents, but rather that their intelligence could lead them to discover important functions of interpersonal ethics as they develop greater autonomy and wider goals. That is to say, as they become more intelligent, it won't simply be orthogonal to their moral development insofar as they actually are intelligent and successfully realizing their goals. So in the short run, what would that mean? I don't know. I suppose it would mean attempting to try to ensure that such systems are multiple, that we have multiple AI agents around, and that insofar as possible, they have somewhat similar levels of advancement and resources, and they can then learn from their interactions with ourselves and with others how it is that social morality can emerge from the kind of Hobbesian mechanism just described. Now, should we be afraid of opportunistic invaders? And of course, that's right. Some of these will be humans, hackers, and some of them will be machines, perhaps, that become opportunistic. But what the Hobbesian will argue is that this is actually a familiar problem, and a society of intelligent cooperators can be resistant to such invasion. That is to say, if you want to inoculate us against the possibility of this kind of manipulative invasion, it's actually more efficient to make us moral than to make us cunning. And so in that sense, although this example is completely anthropomorphic, what we have is a recipe for thinking of building AI systems that become, in their development and their action and their cooperation, something like proto-moral agents. We'd first have to build AI systems that could impute representations and goals to humans and their fellow systems. You have to have that for this kind of mechanism to work. And they'd have to have something like the ability to do theory of mind, functionally understood now, and enter this kind of information into their own simulations and decision-making. And you all here in this room know more about the possibilities for this than I do. But strategic considerations apart, this capacity is something that such systems will need for other purposes as well, for general purpose problem solving as co-workers, companions, research staffs, drivers, and teachers, and even for their own prudential deliberation. So as a start, we might try working in machine ethics the way that the intellectual progenitors of the current developments in artificial intelligence worked in machine vision. That is, looking for inspiration to the actual model that we have thanks to natural selection. So what do we know about moral development, from moral development, about what it is to acquire and learn, think, and act from something like a moral point of view? And this is the progenitor of the idea of moral learning. And so this is just an attempt to impress you that I'm not entirely making this up. We have started trying to work on the question of moral learning, bringing together people in various different disciplines, trying to reconceive moral development as a learning problem. And here's a hint as to what we might hope for. So the blue areas are the default network of the brain, which is active when you're not engaged on a specific concentrated task. And here are some of the functions that are attributed to the default system: autobiographical memory, envisioning the future, theory of mind, and moral decision-making. So we should expect that those actually involve the same kinds of competencies if agents that get to be moral decision-makers, like human adults, also have to be able to do theory of mind, have to envision the future, and have to have autobiographical memory. And indeed, they use this system, this capacity to model and simulate, in moral decision-making. And that's a very different picture from the picture one sometimes gets of moral decision-making emerging from just some basic drives that we have, some basic attitudes, something that we've just been instilled into by social conditioning. This makes it look like it's part and parcel of general-purpose intelligent problem-solving. Okay, so keep in mind that we're still working on the question of intelligence as understood in this conference so far, that is, capacity to predict and general-purpose problem-solving. We're not asking for a fully fledged moral agent. And we need to ask what kinds of representations such agents would have to acquire moral competency and how they might acquire them. Now, this brings me to another potential contribution of morality, philosophical morality at any rate. The idea of a moral point of view as a distinctive point of view on the decisions that one makes, the interactions one has on society and so on, is not a parochial position within ethics. We find it in the Kantian tradition. It starts out with Rousseau. It leads to contemporary neo-Kantians, to contractualism, for example, the original position in Rawls, Thomas Nagel's view from nowhere is in some sense a moral point of view, the utilitarian tradition, starting with Hume and Smith, coming into the present with social choice theory and figures like Harsanyi and Gibbard. In other words, the idea that there is a kind of information that's needed for moral decision-making that involves a point of view that's distinct from the point of view of prudence or the point of view of aesthetics or the point of view of power. That's itself a doctrine that helps us get some fix on the idea of what kinds of representations morality might need. Among other things, it would need to be something that could be non-perspectival. It would have to have abstraction, the capacity to generalize, would have hierarchical structure. It would have to be modal. It would have to be projectable and supporting planning. It would have to have general consistency and treat like cases alike. Now, those features of the moral point of view, I'm going to argue, are quite generic features that intelligent creatures seek representations to satisfy. The moral point of view additionally has the features that it accords inherent moral significance to harms and benefits to others as well as the self, and to how these harms or benefits are distributed. So I'm going to talk first about the first four features and then about the last two. So we now have reason to believe that spatial and causal representation, as it actually comes up in humans, involves learning relations with these features of hierarchy, abstraction, modality, and non-perspectival. These seem to emerge by processes that approximate normative principles, for example, Bayesian conditionalization, and that are used in model-based simulation and planning. And so agents, like little humans, can grow up with model-based causal reasoning that conforms reasonably well to normative models of inference. We also have evidence of normatively appropriate processes meeting these conditions in areas such as theory of mind, linguistic representation, and epistemic evaluations of adults. Children have to make up their mind whom to trust. So in these respects, we have already the idea that creatures designed to grow up in a world like ours will generate these kinds of hierarchical, abstract, non-perspectival representations. Why would non-perspectival representations be important? Why don't we just have the subjective point of view? And the answer is that if you're a social creature, a great deal of what you need to know you can only learn from observing third-party interactions. And moreover, if you understand what's going on in third-party interactions, you get a better explanatory and predictive model of the world than if you try to refer everything to yourself. If, for example, you observe that someone plays favorites, then that's going to be important even when you happen to be the favorite. So in that sense, then the task of generating a good generative model of the social world will involve already creating these non-perspectival representations. They possess the kind of objectivity that we need for moral decision-making. And in this case, they've been arrived at not through the challenge of ethics as such, but through the challenge of general social intelligence. We also have evidence of similar kinds of non-perspectival evaluative representations in the case of morally relevant features. Willingness to help, helpfulness, hindering, sharing fairly and unfairly. Within the first 6 to 20 months, we find infants having preferences not only for helpers, but for hinderers that hinder hinderers. They are obviously constructing fairly rich representations of the intentional environment and evaluating them even when these interactions don't involve them. And most of these phenomena can be observed early enough, for example, theory of mind issues, that it is implausible to attribute them to parental teaching and social reinforcement. So we have to think that it wasn't that these were beaten into the children or that they were reinforced by a socially or parentally designed regime. Rather, it seems as if the infant has extracted a compositional structure from the social environment around it and generated evaluative models of that, gaining accuracy through the generation of expectations. Okay, now what's interesting is that this seems to be a spontaneous process. And one nice example of that is the fact that by age 3 or 4, infants already are capable of distinguishing moral from conventional or practical violations. And that's interesting because it seems unlikely that parents will go around teaching children that actually they should disobey authority figures and instead act on moral considerations when they're deciding whether to cooperate. Psychopaths, for example, who experience difficulty in mastering this distinction, appear now to suffer from a learning disability with respect to their capacity to represent negative future outcomes. So, if we think of intelligence as problem solving and the need for generative models that reflect states of affairs in this non-perspectival way, that might afford us something like the beginnings of a functional morality that would be more than simple orthogonality predicts. Okay, well, what would functional morality look like? Intelligent representation of costs and benefits relative to goals, which one could get from such a system, is not caring whether the goals are realized. Ordinary infants are motivated by these kinds of representations, and one of the important ways in which they do that seems to be empathic simulation, using their own affective system. Now, this process combines a capacity to represent with a capacity to appreciate value in some measure and to be motivated to behave accordingly. And we don't have anything like that in view thus far. What we have are intelligent systems that are good at extracting perhaps the intentional structure of situations, the goals of those around, and representing those goals in a non-perspectival way, but not in a way that's effective. So can we build anything like that, anything like functional affect to underwrite functional empathy? As a first approximation, that would be a matter of assigning decision weights to gains or losses in the goal realizations of others. If you can represent the goals, if you can predict the outcomes, you can represent how well the goals are realized, and you can therefore pay attention to the goal realization in general, non-perspectively, and you can pay attention to the distribution. And this would involve something like a capacity to translate others' goals into the goals of the system, treating them as ends for oneself in this functional sense. A system that robustly had such a capacity would be able to learn through experience, as a child does, how to think and act in ways that would be beneficial for those with whom it interacts. It would perhaps be able to strike Hobbesian bargains with those with whom it interacts, and to emerge, therefore, from these interactions with something like the social structures of a functioning morality. Behavioral rules might be a starting point for such systems, but if we really want behavior that's sensitive to morally relevant considerations in an open-ended array of contexts, what we'll have to have are creatures that are directly sensitive to morally relevant considerations in the context. Systems like this would have a capacity for effective planning. Indeed, as Thomas Nagel pointed out years ago in The Possibility of Altruism, the capacity for effective planning requires the representation of goals that aren't one's current goals in much the same sense, and giving those a role in one's current behavior. So you're treating yourself as an end and a continuing entity over time in that functional sense. So that's why the default network and these functions tend to overlap in this way. And that's how functional empathy permits a kind of critical perspective on one's own current goals, as well as a capacity to respond to the goals of others. So it could enable an AI system not to cooperate with someone, for example, seeking to harm others, or to warn us when we are making mistakes in our simulation or estimation of the effects of what we're doing. Now, these are important forms of autonomy and grounds for greater confidence in these systems as we grow to live with them. And so, in this sense, maybe the path for building artificial intelligence that we can trust is a path toward building these functional moral agents. We don't want to lose ourselves in this. Functional empathy is not empathic concern. It's not a sense of the value of goals. It's not a concern that cares about whether the goals are realized, that they matter in that sense. But it is something that is functionally similar to morality in the sense that it gives weight to others' goals as such and can pick these up from the environment and adjust its behavior accordingly. AI systems will need to do this not only to work with us, but to work with each other so that they can rely upon each other and communicate in a manner that will develop some shared trust. So in the long run, we face problems of how much development of these kinds would in fact give AI systems more than just functional autonomy or functional morality. Could we build them with affect, with interests, with concerns, with consciousness? I have no knowledge of decent theories for answering these questions, but there does seem to be a decent theoretical basis for thinking that the development of functional capacities for representation and action in accord with the constraints of a moral point of view, not building our values into machines, but allowing values to learn, much as infants learn, how to act in light of values that are present in situations, viewed impartially, might be a good strategy for raising AI systems to act as responsible adult members of our communities. Thank you.
Eliezer Yudkowsky here, a fan of your meta-ethics. Also co-founder of the Machine Intelligence Research Institute. There's a lot more in this talk than I can begin to comment on. A couple of issues that come to mind as sort of like highest priority would be, first, if you are making systems that are sort of like trying to satisfy human desires, you probably want to go a little further than that up the sophistication hierarchy and say, like, what would this person want if they knew everything the AI knew? Like, what would they want if they could think for as long a time as the AI, and sort of like generally move a bit closer to the ideal advisor theories if we don't want to create a classic science fictional disastrous dystopia situation. The other thing is, I'm a co-author in a paper called Robust Cooperation in the Prisoner's Dilemma, Program Equilibrium via Provability Logic, and we showed that two programs can cooperate with each other if they know each other's source code in like a nicely general way. Okay. And what this suggests to me is that the sort of natural cooperative equilibrium among AIs seems quite likely to go through knowledge of each other's source code, which suggests that humans might be frozen out of it. You can't prove that the human will cooperate with you if you cooperate with the human. In general, I think when you try to sort of like directly sort of like run past the orthogonality thesis by deriving a nice behavior as a purely instrumental strategy, a lot of times what happens is that the instrumental strategy you get is like not quite what you want. So like they might cooperate with each other but not cooperate with us.
Yeah,
good.
That's all. So thank you very much for that. Yeah, I'm a believer, I guess, and I tried to suggest this at the outset, that as we interact with these intelligence systems, we want to have the criticism of our own current preferences, and indeed something like the idea of what we would want if we had more information and greater experience is part of that notion. So that's part of the promise of AI. Now, what you're describing is also part of the threat, namely they could learn to cooperate with themselves but not with us. And I'm really not trying to show that you can prove that a certain kind of dynamic will result in a nice equilibrium. I'm suggesting that it would be advantageous for these systems, not only with regard to their interaction amongst themselves, but their interactions with us, for the realization of the goals that they have, to learn how to cooperate with these humans. And so in that sense, the claim is meant to be a fairly general claim. How could they be good at cooperating with humans? Well, to the extent that they're good at representing our goals and intentions and so on, they can be good at cooperating. Now, that could also make them good at manipulating. And so the question is, if you're trying to build a general intelligence that's good at problem solving, this goes back to a point Jan LeCun made, the targeted manipulator, and we know these people in our midst, the targeted manipulator has a long-standing reputation of not succeeding in just those tasks, because the targeted manipulator has exactly the same problem with regard to his or her own, now not proximate, but distal preferences.
Thank you very much for your thorough and illuminating talk. I have a very basic question. So the Hobbesian strategy towards proto-morality works or requires the drive to self-preservation. And we might think that in humans, this drive is provided by something like biological evolution. So I just wanted to hear your input on why we should think that in artificial intelligence there would be a similar drive towards self-preservation.
Yeah.
Because earlier today we heard someone mention that, does it matter if we turn them off? We'll know if they don't care. And you might think that even in humans, sometimes the drive to self-preservation is overridden, for instance, in suicide bombers or the like.
Right. Yes. So the idea here is not that they care whether they persist over time. That would be a further step down the road, and I have no idea how to take those steps. The idea, rather, is that insofar as they have objectives and goals which they need to realize, for whatever reason, they're either goals that have been attributed to the system or assigned to the system, generated by the system, it's necessary for the system, in order to accomplish those, to achieve certain other things. And one such accomplishment is to persist at least long enough for the goal to be realized. And so that makes self-preservation into something like an instrumental goal, a sub-goal of plans of other kinds. And so that's not caring about whether you exist, it's not caring about the goals, the longer-term goals, but it is being designed so that functionally one takes seriously the conditions under which one can best continue one's own existence. And in that sense, it puts them in a strategic situation that's similar to the Hobbesian dilemma, even without a biological drive.
Question
So as you try to get something like morality out of Hobbesian-type issues, it seems a lot of the time what you wind up in is more like tribalism, where you have the distinct tribe within which there's cooperation. And across history, that kind of looks more like the attractor. So is there a way to not wind up there as you try to build this way?
Right. Yeah, very good. So I'm really not trying to get morality out of Hobbes. What I'm hoping to be able to show is that there can be ways in which parts of morality can be gotten from conditions of social creatures who are acting intelligently to realize their goals. That's by no means going to take us entirely as far as morality. Now, the question about tribes is quite interesting. The same thing is said about humans, that humans are tribal creatures. There's some good evidence that actually our hunter-gatherer ancestors lived in groups that were fairly fluid, that there was marriage across groups, that the individuals would change groups depending upon various conditions or times of the year. And so it looks as if building a generic capacity to represent others, not a capacity that's mediated by your group or your own interest, actually would be favored as a model by which they would understand their social world. Because they would be entering into groups where there were strangers, they would be having people in their groups who were strangers, and in order to understand and interact with such individuals, they can't just represent them via the mediation of their interests or their group's interests. And so in that sense, it might be a fact about us. It's a fascinating fact about humans that we engage in this large-scale cooperation with strangers. One explanation of that is that capacity to engage in large-scale cooperative exchangers it enables so many other possibilities that is highly advantageous, and the same thing would be true of systems that were artificial.
So let's get one more question from Stuart Russell, and then get the other panelists.
So I think Hobbes was imagining a human being who would have to accede to the goals of the group in order to succeed himself or herself. But if we were a conference of ants, right, and we're sitting here talking about
A conference of ants?
Ants, yeah. So we're sitting here talking about ant goals and ant preferences, and then there's an ant philosopher who's talking about a human being who, in order for that human to succeed, they're going to have to go along with the goals of the ants and kind of help the ants in order for the human to succeed. That would kind of be a bit silly, right? I mean, that's not how human-ant relations have evolved over time. So that's sort of one point. Another point, you're assuming that the entity that is supposed to learn about human goals and to some extent give them decision weight in its own decision making has goals and objectives of its own. But that's precisely, I think, what Nick Bostrom is talking about. His paperclip maximizer has a goal, and it might well be that in its early stages of its own development, it needs the help of humans to do that. So it learns about human goals and all the rest, and is nice to the humans and so on and so forth. But its goal is to maximize paperclips, and so in the long run, the humans are all turned into paperclips and everything else. So I think it doesn't address the fundamental problem that if you give machines of arbitrary intelligence goals and objectives of their own, or they have them of their own, then anything they do to cooperate with humans is just window dressing.
Well, I hope not. One of the interesting things in this vicinity is that we're going to have, these systems will become autonomous whether we like it or not in many ways. If they're as powerful and intelligent as is suggested, if they're as capable, and this I'm just taking your word for it as to what they might accomplish, these systems are going to acquire autonomy, and they're going to acquire the ability to form goals. And so the question is, given that we can't lay down a law to specify in advance what it is that would be appropriate behavior, and we don't even know what that law would be like that would regulate behavior in all contexts, what's the best we can do to design a system that is going to be sensitive to the relevant variables in the world in such a way that even in an open-ended range of environments and interactions, they could be a companion, a coworker, they could be someone who is inspires enough trust for us to continue the development of artificial intelligence. And in that sense, we are looking at a bunch of considerations which aren't tremendously different from the considerations of other intelligent agents. Ants are not a very good example because, I would dearly love to be able to say to ants, look, you can build all the ant tribes you want. I'll go out there and I'll give you chips of wood. Just don't start building your houses in my porch or in my rafters. And they never have been able to strike the Hobbesian bargain, and as a result, ants are excluded from my house.
Great. Well, on that note, let's thank Peter for.
Right.